Okay, now we come to the actual topic of the chapter, linear programming. Okay, so linear programming is a way of finding a number of possible solutions to a problem given a number of constraints. Okay, here is your question. In the following questions, draw both axes numbered from 0 to 12. Okay, so they are just giving you a hint here. I mean, when you draw your coordinate axis, there is always this question, right? Like how long should your axis be? So here they have given you, you have to draw your axis numbered from 0 to 12. So you don't really need the negative part of your axis. You can just draw it like just the positive part. So you can draw it like this. Okay. Okay. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay.
Okay.
So you've answered the first part. For each question, write an inequality for each statement. Write an inequality for each statement. Graph the inequalities, leaving the region which satisfies the inequalities unshaded. Using your graph, state one solution which satisfies all the inequalities simultaneously. Okay, so here is your question. A taxi firm has at its disposal one morning a car and a minibus for hire. During the morning, it makes X car trips and Y minibus trips. It makes at least 5 car trips. Okay, so here are your statements. It makes at least 5 car trips. So what is the inequality for that statement? It makes at least 5 car trips.
Y.
No, car trips is X. X car trips. The number of car trips is X.
X less than or equal to 5.
It makes at least 5 car trips. So it makes 5 or more, right? 5, 6, 7 like that. That is what at least means, right? So X is greater than or equal to, right?
Yes, to 5.
Equal to 5. At least 5 means 5 is also acceptable, right?
Yes.
So it's you can write greater than or equal to 5. Then it makes between 2 and 8 minibus trips. Between 2 and 8 minibus trips. So the number of minibus trips is Y, right?
Yes.
So Y is between 2 and 8. So what's the inequality for that?
So 2 less than or equal to Y less than 8.
Yeah, so you might be wondering whether to put less than or equal to, right?
Yes.
So I checked the answer in your textbook, so it is less than only. So when you see the word between, it means these numbers are not included. Okay, so between 2 and 8 means it is 3, 4, 5, 6, 7. It cannot be 2, it cannot be 8 also. Okay, so that's why you need to use less than in such inequalities, not less than or equal to. Okay.
Okay.
Then the total number of car and minibus trips does not exceed 12.
So they are all less than 12.
What is less than 12?
Uh, do not exceed trips.
What is less than 12?
Y and X.
The total number of car and bus mini trips. What does that mean? Total number of car and minibus trips means, how will you represent that symbolically?
X less than 12. X and
It's
plus
total number of
plus
car.
Y.
Yes. So total number of car and minibus means X plus Y, right?
Yeah.
Does not exceed 12. So it's less than 12, right?
Yes.
Can it be equal to 12?
No.
It should not exceed 12. Does not exceed.
Equal.
Equal to is fine, right?
Yes.
Because it does not exceed. If it's equal to 12, it does not exceed 12, right?
Yes.
It exceeds 12 only when it is 13 or higher, right?
Yes.
So you can put less than or equal to, isn't it?
Yes.
So now you have your inequalities, right? What are your inequalities again? Can you read them out?
X less than or equal to 5.
Greater than or equal to 5.
Greater than equal to 5.
Hmm.
2 less than Y less than 8.
Hmm.
X plus Y less than or equal to 12.
12. Okay. So you have answered this A part. Graph the inequalities leaving the region which satisfies the inequalities unshaded. You know how to do this, right?
Yes.
This is what we just did some time back, right? Graphing the inequalities. Graphing more than one inequality. And here also you have to leave the region which satisfies the inequalities unshaded. So just like what we did here. Okay. X greater than or equal to 5. Graphing that is straightforward, right? Isn't it? X plus Y less than or equal to 12 is also fairly simple, right?
Yes.
But how do you graph this? 2 less than Y less than 8.
Everything in less than 2 and equal to 8. Less more than 2
Huh.
less than 8.
So
3
more than 2 and less than 8. So actually um, your Y equal to 2 is going to look like this, right? Why are we drawing dotted lines?
because it's not equal.
Yeah. And where is Y equal to 8? Here, right?
Yes.
So you draw a dotted line here. Okay. And then so actually your solution will be between 2 and 8, right?
Yes.
The region in the middle is going to be your solution, right? Isn't it?
Yes.
But you should leave that unshaded. Okay.
Okay.
So you should shade above 8 like this. And you should shade
Below 8.
below 2. Right.
Yes.
So this is what you shade for the second inequality. Then what do you shade for the, okay, let's do this completely. How do you draw the x greater than or equal to 5? X greater than or equal to 5. Quick. X greater than or equal to 5 means first you should 3,
draw a line in 5.
2, 3, 4, 5. You should draw a vertical line
In 5.
here, right?
Yes. And then so you shade this area.
1 second. Greater than or equal to 5. So your actual solution is
This side.
greater than or equal to 5.
Dotted line.
X greater than, you see your inequality is x greater than or equal to 5. So which side of this line is your solution?
This one.
This one. So you should shade
this
one, right?
Yes.
So this side you should shade. So you have shaded two of the inequalities now. Now, the last one, x plus y less than or equal to 12. How do you do this? First you
One.
make a table. Yes, you can put, let's say, let's put some big numbers. Put x equal to 5. Y will be
7.
7, and let's put x equal to 6.
Is 6.
Y is also 6, right?
Yes.
So 5 7 means 5 7 5 7. It's here, right?
Yes.
Then 6 6 is, there is 6 6 6 is here, right?
Yes.
6 is here. So we just draw a line joining these two, right? This clear. So that's your line. Now x plus y should be less than or equal to 12. So can you tell me, is 0 0 part of this solution?
No.
Is 0 0, does that satisfy this inequality?
Yes.
So the origin is part of your solution, right?
Yes.
So which side should you shade?
This side.
Very good. So you shade above this line like this. Okay, now you have shaded, you have drawn all the graphs, right?
Yes.
So what is your conclusion?
This in the unshaded.
The unshaded region is your solution. Okay. We have done this B part. Using your graph, state one solution which satisfies all the inequalities simultaneously. So you need to state one solution which satisfies all the inequalities. So one solution actually means one value of x and y, right? That's what you mean by a solution, right?
So 4, 6 and 4.
6 and
4.
You mean this point? Okay, this point here.
Yes.
Very good. That's a valid solution. So what does it mean when you say 6 and 4? What does it mean in real life? What is 6? What is 4? Yeah, what is 6 and in the problem? Yeah.
And car and
So can you say that again? Number of car trips is?
and mini.
Yeah. So tell me the numbers. Number of car trips.
Number of car trips and
Yeah, tell me the numbers.
6 and 5. 6. Okay. And there's
Car trips is 6 and
when the car trips is 6, mini will be 4.
minibus trips is
4.
4. Okay, that is one solution, right?
Yes.
Are there other solutions?
Yes.
Of course there are other solutions, right? You can take this point, you can take this point, you can take this point, you can take a lot of points, right?
Yes.
But can you take this point here?
No.
Because it's a dotted line, right?
Yes.
So you cannot take any point on this dotted line because the line is not part of the solution. Can you take a point on this line here? This line.
Yes.
You can, because that line is also part of the solution. Okay.
Okay.
Understood. And also another point is you need to take integer values, right? Because the number of trips is always going to be an integer, right? You cannot have 2.5 car trips or 1.5 minibus trips, right?
Yes.
So you should just choose integer values of x and y which fall in this region. Understood?
Yes.
So this is how you solve these problems. And with that we have finished the chapter linear programming.